Welcome everybody to another ZKast video. This is part of my thought leadership series where I interview different executives from different companies to get their take on some of the more interesting and transformative technologies that we're seeing emerge today. This, of course, is done in conjunction with my media partner eWEEK as part of their eSpeak series. Today's guest, actually, I'm really delighted to have today's guest because this is a really cool technology and something we've all heard a lot about, but maybe don't quite understand. It's Özer D, VP of Marketing for a pretty interesting company called Celona Networks. Özer, why don't you correct me on the pronunciation of your last name? My last name's Caravalla. Everybody always mispronounces it, so I know your pain. But tell me a little bit about yourself and what the heck Celona does.
So Lee, thanks for having me. It's Özer Dondurmacıoğlu. It's a great conversation starter when you meet new people. It also happens to mean son of an ice cream maker. So,
oh, well, where's my ice cream?
On my retirement job. So, hey, listen, thanks again for having me. I've been part of the enterprise networking industry for the last 20 years. Celona is my third startup journey. And what is Celona trying to do? We're trying to push the boundaries of enterprise wireless even more. I think after spending 10 plus years in Wi-Fi, enterprise Wi-Fi networks, myself and several others in the team, we thought that Wi-Fi is just tip of the iceberg, that mobility and wireless technologies are addictive. They create interesting habits of behavior in enterprise IT systems, architecture, purchasing, and different behaviors and demands from their core audience, which is the people who work at these facilities and buildings and what they're trying to get done. So push the boundaries of enterprise wireless. There's a little bit more to the Celona story, which I think is going to come up with your questions, but that's how the idea got started. We essentially take advantage of the CBRS spectrum in the United States to start with. For those of you who don't know what CBRS spectrum is, essentially the most exciting news for enterprise wireless since Wi-Fi, I think. It's because it allows for the first time an enterprise IT or OT teams to get access to cellular wireless, LTE and 5G wireless technology for free without having to pay licensing fees, without having to go through a service provider. You just buy a Celona access point, you plug it in, indoors, outdoors, you got access to that technology. And that technology opens doors for a variety of different use cases we talk about. But this is additional spectrum. And so far, after talking to 100 plus enterprise customers out there, I haven't run into anyone that says, oh, we don't like more spectrum. So people are excited about CBRS. And we're just trying to remove as much friction as possible in their adoption of the technology so that they can get going by taking advantage of it. So that's kind of the introduction, but hopefully we get to give people more context as we talk.
Yeah, certainly the pursuit of good quality wireless spectrum is part of Maslow's hierarchy of needs, or at least it should be, right? It's right down there with food and water. So you guys do private 5G using CBRS. Tell me why we need this, right? Admittedly, you mentioned Wi-Fi. Wi-Fi has been around a long time. It's ubiquitous. The Wi-Fi 6 vendors tell me that, Wi-Fi 6 is going to solve all our problems. So what are you doing that's not being addressed by Wi-Fi 6?
Yeah, it's a great question. We get that question a lot. There's really three things. The first one is just by the nature of the spectrum operation. So CBRS is a spectrum where the wireless technologies on top run. So LTE today and 5G in the future. So the ecosystem, the industry said, in the United States on the CBRS spectrum, we're going to run cellular wireless technology. It's not going to be Wi-Fi, it's going to be cellular wireless technology. And this spectrum is designed in such a way that any access point that you deploy by design, by law, set by FCC, runs on interference-free mode. So a client device and an access point always operates on an interference-free channel. Nearby networks don't get to interfere with you, just the way the spectrum operation is designed, and your network don't get to interfere with your neighboring environments. So when you go to an enterprise IT team and say, hey, I get to give you an interference-free spectrum, no noise, no neighboring networks, and they go, okay, sounds like I can put some important stuff on this channel. It doesn't mean that Wi-Fi is useless anymore. It just means that I have an extra express lane. The second thing is the technology is designed in such a way to promise really, really low latency as devices move around. So if you have high mobility devices, let's say automated mobile robots in a warehouse, nurses running between different rooms in a hospital, trying to stay connected on voice, imagine low latency, real-time compute stuff. The handover between this infrastructure, these access points, are handled by the infrastructure and they're seamless. So there's no dropped connections as people move around, as devices move around. And the third piece is probably the most important for the techies out there. In addition to being able to offer just the quality of service for a specific application, just like we do today with Wi-Fi, you actually get to guarantee a specific error rate, latency, and throughput metric on top of that quality of service. So it's like QoS++. We call this technology Celona microslicing. We will get into it more. But I am able to say, this video camera gets this much bandwidth. This voice traffic gets this much latency, which we only got to do on wires before. Now we get to do that on wireless too. So these are just fundamental differences when compared to something like Wi-Fi. Again, Wi-Fi networks are going to be there, but this express lane gives us a lot more options. Hope that makes sense.
Yeah, so the problem that we have today where if I'm doing my Zoom call or a Cisco WebEx call and somebody turns a microwave on and it interferes with my connection, that goes away. Or I think I'm a former network engineer, right? And so we knew with Wi-Fi, if you just crank up the power on your access point, it would, supersede the other ones. All those type of problems go away, right?
Exactly. Yeah. I mean, the idea of network segmentation for enterprise IT teams start with their need to say, look, I have designed my Wi-Fi network when there were two types of devices on the Wi-Fi network. It's been 3 years. Now I have 5 types of devices. And by the way, the last 2 device types that we put onto the Wi-Fi network apparently are super critical for business operations, right? Because people are going through more digitization. They're converting more business process to digital tools and sensors and mobile devices and applications. So they never imagined some of the things that they're putting on Wi-Fi today. And when we go to them and say, look, let's take those 2, put them on an express lane, let's guarantee some throughput performance, they're ready to go as long as the underlying technology is useful. So there's a difference between stuff that has to work on a wireless network and a stuff is good to have on a wireless network. So we're really targeting stuff that has to work when connected on wireless.
You bring up a good point, because when I think of some of the conversations I've had with business leaders about the return to work and the safe workplace, they're outfitting buildings now with a lot of temperature sensors, automatic, scanners, environmental sensors, things like that to make sure the environment's safe. Even I talked to one company that's thinking of having a cleaning robot going after hours and disinfecting the whole place. So those are the types of things, it seems that, if it's subject to flakiness of Wi-Fi, that's going to compromise your workplace actually, and could have some pretty catastrophic situations. So exactly. Let's say I buy into the private 5G model. Now, there's lots of choices for companies to buy 5G, right? Wouldn't I just go to a Nokia, Mavenir, company like that already sells 5G to the service providers? What are you doing differently?
So here's the story actually unfolds. I think CBRS spectrum has been around for the last year plus, although it has been in development with the CBRS/ONGO Alliance for the last 4+ years. It's been ratified, commercially available for use for the last year. So we're still in the early stages of the technology. What that means is the ecosystem is growing, customers' understanding is growing, and people who adapt the technology today are early adopters. So early adopters, why do they even think about CBRS when they talk to us? Because they have an existing need. an operational technology team or an innovation team in these enterprise environments said, you know what, we're going to automate product picking from the shelves in a warehouse. We're going to, deploy a new communication tool for nurses. We're going to digitize, body counting using computer vision sensors. And nobody asked the networking team, they kind of came up with these big ideas. They started spending tons of dollars on enabling this application, rolling out compute resources and signing up for new services and building new tools and operationalize this whole thing. And they bring it to the networking team and say, hey, why don't you connect this stuff? And the networking team goes, well, you know what? I need additional lane of connectivity, aka CBRS in this scenario. And I need something that works with my existing network. I don't want a separate set of cables. I don't want a separate set of firewall rules. I don't want a separate set of switches. I don't want a mobile network operator trying to extend their network in my environment. I want stuff that fits right in to the policies that I created for users and devices. I need something to protect the application quality within my infrastructure, adapting to my policy. And that's exactly what we try to do. So instead of saying, hey, we got a public LTE 5G wireless system design that we've been using all of our lives for the last 20 years and force fit that design in an enterprise building, we kind of took a different approach at Celona. We said, let's ask the networking guy first what he needs, and then design a system that fits to its existing infrastructure. And that has been the key differentiator for us. So as a enterprise IT team, let's say that they have an issue with our deployment. They email one support line. If they are going through an upgrade to enable new features, they just upgrade one piece of software from us. If they want to manage the network remotely using a cloud dashboard, we provide that. We provide the SIM cards that go into devices. We provide the mobile core software and everything else that they need to set up a pilot network in an afternoon. Compared to the service provider model, which is rightfully so, depends on multiple products, because each product is supposed to scale to millions of subscribers across millions of square feet of space in cities, right? We don't have that problem here. The problem statement is relatively different. I have 3 warehouses, I need 20 APs, I have 200 clients, and I need them to be connected reliably. So since the problem statement is different, the architectural approach with us is very different too. Hope that answers the question.
It does, yeah. Now, when I think of 5G, for whatever reason, so when I think of Wi-Fi actually first, the things that come to mind are it's fast to deploy, it's easy to deploy, and it's relatively inexpensive, right? So how is Celona's private 5G comparatively in those areas? Is it complicated? Is it more expensive?
Yeah, so what we have done is, again, the idea is to make sure that enterprise IT and OT networking teams feel comfortable with the technology. Today, since we're in the early stages of the market, nobody has a budget line item that says, hey, next month, let's spend this much on CBRS. I mean, they don't even know what CBRS is usually, right? So, so we have to, when we introduce this new technology to their bottom line budget planning, they have to see some savings either through less cabling, either through redirecting budget from possibly their existing service provider contracts and other means. And that budget line item should not create a sticker shock. Sometimes it does, given the existing solutions in the market. And in order not to create that sticker shock, we said, per square footage, our solution should be equivalent to a Wi-Fi based solution for that same square footage. So it should be 1-to-1. And honestly, after going through a variety of different designs and deployments, what we realized is we can actually be even more cost effective on especially outdoor deployments, because the outdoor coverage patterns of CBRS, given the higher power levels you can use and a variety of other things, you can actually cover quite a large area outdoors for connectivity. So, but let's just assume for the sake of this discussion, we're trying to match it one-to-one such that IT and OT networking teams can easily consume and easily justify the investment. The ROI will be there in the upcoming years, right? Hopefully we will see examples of case studies where customers realize X amount of ROI, and that drives further discussion within our customer base. But right now we're working hard to not cause that sticker shock.
Yeah. Now you mentioned something called QoS Plus, right? I'm assuming if you're using this thing for mission critical apps, that quality's got to be there. So can you give me a bit more color on what exactly that is and how it works and how you handle, ensuring quality?
Yeah, absolutely. I mean, in a corporate network today, using your SD-WAN solution, switching, Wi-Fi solution, you can set up policies that says these group of devices and these group of applications are prioritized over the others. It's just standard IP networking, and when it meets Wi-Fi, there are certain rules you need to follow. When it meets your wide area network, there are certain configurations you have to do. That did not exist before we essentially provided our solution for cellular wireless. There was no translation of enterprise quality of service policies to the way cellular wireless works over the air. So that first problem solved. But then we added a capability of cellular wireless on top. By design, by standard, LTE and 5G allows you to guarantee a specific throughput number or a latency metric or a packet error rate. So you're deploying video cameras on CBRS LTE because you don't want to spend the money on fiber and wires. You can say those cameras get 3 megabits per second guaranteed minimum throughput. On top of that, they're prioritized. You have voice running in that same environment. You can say maximum of 100 milliseconds latency for those voice-enabled smartphones, again, running on the same CBRS network. And then, by the way, this is actually a warehouse with a bunch of automation going on. We have automated mobile robots picking up products and delivering products between different shelves. Let's make sure that their packet error rate is less than X%, right? And all of those things, all of those traffic types are prioritized, but in addition to that, there's an SLA metric assigned to them. So that's why I call QoS++. And that's a brand new concept for, of course, enterprise wireless. We're able to do that on wires in the past, but now we're bringing that wire-like capability to wireless too.
Yeah, well, that's cool. So it's not just plus, it's plus plus. So if I'm a network engineer and I'm interested in getting started with this, how do I get started, and how does it relate to Wi-Fi? Am I doing a rip and replace? Does it coexist? What's the path forward here?
Yeah, I think identifying the use case, the applications that are causing you trouble in the sense that, hey, you might take advantage of a new express lane or wireless connectivity. Once we identify that use case, there's the device ecosystem, smartphones, tablets, IoT gateways, variety of other devices have grown rapidly. There's over 100 plus device options out there. So we go sit down with our, customer contacts. We do a rough design, number of access points required, square footage, type of applications running. We recommend them device options if they already don't have any. And we start with a quick trial. It usually takes, 30 days. It takes an afternoon to set up. We test and validate how we can integrate with their environment. But if somebody is, proficient in deploying Ethernet switching and Wi-Fi today, them understanding how to deploy our solution literally is a couple of hours. So we're not talking about huge, friction in between them being able to use the product and our capabilities. Ultimately, networking team is, again, one audience. We just have to also make sure that the application teams know the benefit. So there might be some additional education we need to do beyond the networking teams to say, hey, what is the end goal here? Are we targeting application quality? Are we targeting, more applications to be deployed on the network? Whatever it might be. So we usually bring in the business operations or operational technology teams to the table as well to get that nailed for the success of the deployment. Hope that makes sense.
Yeah, that does make sense. And I just want to make sure everybody fully understands this. So this sets up a lot like Wi-Fi. With Wi-Fi, I've got access points and a controller. With you, I've got access points and a controller. So if I can do one, I can easily do the other, right? There's no magic. And so I don't know how many customers you have now, but can you give me a couple of examples of where companies have used this? We've talked about some theoretical use case, but can you give me some actual live ones?
Yeah, absolutely. Actually, the use cases that I mentioned are directly from some of our deployments. We're in the middle of deploying 2 warehouses with automated mobile robots moving really fast between shelves and delivering products and picking up products. Wi-Fi is still available in that facility for user, staff, device connectivity, but robots went onto their express lane with CBRS.
Did they try the robots on Wi-Fi first?
They have. It required quite a bit of dense Wi-Fi design, and the handovers were taking place, but not at the latency level that they would like to see. The operational technology team would like to see. So this was let's improve the performance of an existing application type of use case.
Okay.
And we're in the middle of a deployment at a hospital where the voice collaboration tool, which is also used for electronic medical record access, is actually deployed on-prem. So the voice servers, voice application devices, which are iPhone SEs, they all are on-prem. There's no cloud connectivity. And it's a private voice system. And they said, hey, patient devices and BYOD devices can stay on Wi-Fi, but we want these iPhones to live on a different spectrum and a different technology. And thankfully, iPhone SEs are very affordable, but they also support CBRS today. So they're able to kind of migrate that. One very, popular, I don't want to call it emerging anymore because, we're in the middle of deployments today, is our ability to redirect the capabilities of our outdoor access points towards a county-wide broadband. So as you probably heard, there's quite a bit of initiatives across the country in the United States to bridge the digital divide, right? Not every home, not every student has access to reliable broadband connectivity, which clearly is going to be a requirement going forward, even after we go beyond COVID. And deploying a private mobile network instead of giving students a router that connects to a public mobile network with certain amount of monthly data charges, of course, much more effective. So a lot of the counties out there are looking at our solution, deploying, piloting our solution to provide large area coverage and for broadband connectivity for students' homes. That's emerging quite fast, actually, and it's very popular and it's very cost effective for these counties and school districts.
Yeah, I can see that being an ideal use case, especially in inner cities where the population density is high. And this has been something I've been on my soapbox about for a while. For this country to not have accessible broadband everywhere is frankly an embarrassment, right? If you look at much smaller countries, much poorer countries, that don't have the resources the United States has better broadband access than we do. And it's an embarrassment. So if you can help fix that, that'd be great, and especially with so many kids doing school at home here.
Right. So and those networks, those citywide, countywide networks, they're there will be a student application, right, which is generally Zoom right now. So our same benefit of enforcing a bandwidth and latency can be done in that context. But now you have this private mobile network in your outdoor environment as a county. What do? Well, maybe next step is to put push-to-talk handsets for your staff. As they roam around the county, they have access to push-to-talk right away, right? Same network, you just pay for the device and you're up and running. Maybe it's the security surveillance video cameras in key parts of the city that you were not able to deploy cameras before because of cost, fiber, trenching, and a variety of different things that you spend money on. Now you can just pop in cameras wherever you want. It's your private mobile network. So we call them smart community initiatives. I think this idea of bridging the digital divide is the Kickstarter to a variety of other use cases in these smart communities.
Yeah, I don't think people realize how game changing that is from a community perspective. I interviewed the chief of police from Dubai a couple of years ago, and they have 60,000 cameras around the city. Now they had to wire everything up, obviously, but with your technology, that could have been done a lot faster and cheaper. But it's created a completely different type of environment where females can feel safe walking around at 11 o'clock at night and not worried about being attacked because there's cameras everywhere. The police don't need to chase people through the streets because you just follow the person, on camera and stuff. And so it completely changed the dynamics of the city area. So kudos to you guys for doing that. Now, I'm curious about the coexistence of the two technologies, Wi-Fi and 5G. At VMworld, Pat Gelsinger's last keynote, he actually made a pretty bold prediction and said 5G would eventually displace Wi-Fi globally. Do you believe that's true, or do you think we'll have these two coexist for a while?
I think they will continue to coexist, but there's a asterisk to, I think, his comment. And I think he's coming from the compute world, right? Cloud/compute world, which is a world that is in colliding with the traditional enterprise network infrastructure. So I've been part of enterprise networking companies where we would treat the underlying core operating system in the campus as its own island. It would be a specialized firmware, like Cisco iOS or Aruba's version, Aruba OS, and the like. It would not talk cloud. It would not talk compute. It would not be a virtualized infrastructure for a very long time. And slowly, cloud networking started to emerge. And we pushed the management layer to the cloud and kept the traditional network operating system in the campus as is. But then VMware, AWS, Azure, Google, what they're really saying is, why don't we just take the cloud native software capabilities we have and start making them useful at the edge as well? The whole push around edge compute. So we see this train of networking trying to be more cloudy, right? And this cloud team trying to be more relevant in the campus, and they're going to collide. Yeah. And 5G is actually a great place to collide because the 5G standard says your network operating system should be cloud native. You should run your network functions that are traditionally buried in a specialized firmware inside a switching box, inside a controller. That should be made up of microservices. So 5G actually calls for that. So now, if you're a networking people worried about wireless connectivity, if you're a compute person worried about cloud native software, in 5G, you see those two worlds coming together. And this is the exciting part about Celona, because that's the vision that we set out for ourselves, right? Our network operating system should be cloud native from day one, which is, and we should be 5G ready because it allows us to push enterprise connectivity beyond what it is today. So I kind of read comments from the compute world saying 5G is going to change enterprises because they're thinking, okay, the underlying campus operating system is about to get disrupted. And, we welcome that challenge. We want to be part of that conversation. And I think you're going to see us and hear us talk about that more in the upcoming weeks and months.
Well, Özer, thanks very much for joining me. That was a fascinating discussion, right? So we talked about 5G and the differences with Wi-Fi, and so I think the big lesson here for the enterprise IT people is that 5G is coming to the enterprise, and it's going to be great for mission critical systems. I've actually talked to many companies that have tried to deploy mission critical systems on Wi-Fi and had those projects fail. So hopefully this will take care of this. So anyways, on behalf of Özer D from Celona Networks, I'm Zeus Caravala. Thanks for joining me on the ZKast, and see you next week.
Absolutely. Thanks for having me, Zeus. Thanks, everyone.